Hello, today I will be discussing in this video what is the difference between flowchart versus an algorithm. Flowchart versus an algorithm. Right. So in this video very important topic is I will discuss first what are the symbol we will be using it for flowchart and how to design an algorithm for problem statements. Right, so we'll be solving some of the problems on these two techniques. The flowchart versus algorithm, they may ask some questions for 4 marks or 5 marks in exam. I'll be simplifies it here. A flowchart versus an algorithm. Flowchart is a pictorial representation of or graphical representation of program. Algorithm is a finite sequence of well-defined steps for solving a problems. That is the first difference. Second difference, it is a drawn using a various symbols. You can use various symbols. Here it is written in the natural language like a English. And flowchart is very easy to understand because since it is a graphical representation, but whereas an algorithm little difficult as compared to the flowchart. Another difference is easy to show branching and looping in terms of flowchart, but whereas in algorithm it is showing very difficult branching and looping, and it is very tough to understanding branching or looping conditions. Another difference is here, flowchart for big problem is impractical. So flowchart is very useful for smaller problems, not suitable for bigger problems. But whereas an algorithm can be written for any problems, even for smaller and bigger problems. So these are the major differences between the flowchart and algorithm. So each one of them having their own advantages and little limitation also there. So let us move to the topic is symbols used in flowchart. Right, so what are the symbol we'll be using it for flowchart? The first symbol, it is a oval symbol. You can use it for starting of the program or stop the program. This kind of symbol we'll be using it for it. And rectangular kind of symbol using for process, right? Any calculation, process, or statement can go with this kind of symbols. Another symbol, if I want to call any subroutine is nothing but sub functions within the main function, you can use this kind of symbol. Another symbol is here, I wanted to show the input or output in a flowchart, you have to go with this kind of symbol, right? So another kind of symbol is I wanted to show any decision making, looping or branching, you have to use this kind of symbol. It is like a diamond shaped symbol, right? So when I wanted to show any data flowing in and out of it, you have to use the arrows, right? So these are the major symbol we'll be using it for flowchart diagram drawing, right, for particular problem. So again you have to be, these are the individual symbol we'll be using it for solving or writing a flowchart for particular problems. Let us take, I'll use this symbol how to draw the flowchart for particular problems we'll be seeing in a short while. Let us take the example, number is positive or negative. How do you write the flowchart for this? At the same time, how do you write an algorithm for positive or negative number? As we all know that how to start flowchart symbol, you have to use the whole kind of symbol. So you have to start the problem, then it will be moved to the next step. You have to read this number. You have to read the number, then only you can decide it, is it a positive or negative. How do you read this symbol? You will be using it for inputting. So input symbol indicated like this, right? So read the number, then you have to test it. How to test it? You have to use the decision making, right? You have to use the decision making diamond shape, right? So then you have to check the condition is whatever the number you read it, you have to check that is the number is greater than equal to 0, then it is becomes true, then it will go and print the positive number, right? Print number is positive. If at all its number is not greater than equal to 0, then it is showing false, right? So once it is true, print that positive number, stop. If at all it is a false, it will print the negative number, then it will stop. Is it very easy, right? So easy to write the flowchart for a smaller number, a smaller problem. How do you write the algorithm for parallelly? Look at that. The first it has to read the number. What is the read? If you read it, then you have to check the step it. You have to check the number is greater than equal to 0. Go to step 4. That step 4 is nothing but you have to print the positive number. Otherwise, it will print the negative number. Go to step 5. Step 5 is nothing but you have to stop it. Step 4 is nothing but print that positive number. Step 5 is you have to stop. This will be indicate the finite sequence of statement to draw the algorithm, write the algorithm for the particular problem statement like this number is positive or negative. So flowchart you have to write it like this and correspondingly you can write an algorithm. I hope you understood this concept. Let us move to the one more problem, how to use the flowchart and algorithm. Right, the number is odd or even. First of all, try to understand how do you find out the given number is odd or even. As usual, I'll start first flowchart starting with the whole symbol, then move on to read the number, then you have to check that number. How to check that? Is the number which is modulus operator. That means whenever any number divide by 2 will get the remainder is 0, then it equal to true. If it all true is that number is even, print number is even, then you have to stop. Suppose that number is not gives the remainder as 0, which is not given to 0, then it is become false, then it print a number as odd, then stop. Right? So easy to write a flowchart. Look at how to write an algorithm. There is an algorithm. Read that number, then you have to test it. You have to check the number is gives the remainder is 0. If number mod 2, mod is nothing but a percentage, that will gets the whenever this number divide by 2, will you get that number as a remainder 0, which is equal to 0. Go to step 4. Step 4 nothing but to print the even number as even. Otherwise, if print number is odd, go to step 5. Step 5 means you have to stop it. Okay, so you have to stop it. So I hope you understand this problem as well. Let us move to the another problem. So largest number from two numbers. Largest number from two numbers. Right, we will have two numbers. Then you have to find out which is the largest number. First you have to write the flowchart, then you can write the algorithm. So as usual you have to start with the start symbol, then move on to read the two numbers A and B. Then you have to check these two numbers, which number is greater than other number, using the addition symbol. Is A is greater than B, then it is big. If at all is A is greater than B, then it become true, then A will be the largest one, and stop. Suppose this condition is become false, that means A is not greater than B, it become false. Print B is a large, then stop. How do you write similarly for as a algorithm? Read the two numbers A and B, then you have to check if A is greater than B. Go to step 4. Step 4 means you have to print A as a largest number. Then step 3, print B is the largest number. Go to step 5, right? So step 5 is you have to stop it, right? The B is right. Stop. Look at this. So both are more or less similar, but little difficult to writing in algorithm. So flowchart is very easy. So hope you understand again this problem as well. To practice one or two problem like this, then it becomes so easy to write any problem flowchart and its algorithm. So if we can go one more problem, right? So that is the largest number from three numbers, and the earlier one you have seen the largest. Find out the two number, which number will be the largest one. Now they given three numbers, which one will be the largest one. For that you have to write the algorithm, flowchart. You have to start again, read the three numbers. You have to which number will be largest as compared to other two numbers. Then you have to test again. A is greater than B. If at all it is a true, then again A as tested with B, and also you have to test with a C, right? Again you have to A is greater than C, then A will be the true, A will be the largest one. Then it will stop. Suppose false, then C will be the largest, then stop. Suppose another case, in this case this decision itself fail, then we will take it false. B has to test it with C, B is greater than C, true, then it will go and print B as a largest and stop. If at all it is a false, then C will be the largest, then it will stop. Look at that, how big it is. So as and when the largest problem statement, or it is very difficult to write the flowchart for larger, very complex problems. So that's what we are always suggesting algorithm for the complicated problem. For some smaller or very easy problems, complexity is very less, we could use that flowchart, right? So algorithm is looked at like this. The read ABC. If A is greater than B, go to step 5. What is that? You have to test again A as compared with C. If B is greater than C, go to step 8. So print C, largest number, go to step 9. What is this 5? 5 is indicate if A greater than C, go to step 7. What is here? It is print C is the largest number, go to step 9. Print A is the largest number, go to step 9. Then print B is largest number, right? So what is step 9? Step 9 is always indicating that stop. Look at that, A is compared with B, then A is compared with C, then A would be the largest number. Go to and stop the process. If at all it is not it is B. B is A is not greater than B is greater than C, then go to step 8. What is step 8? B is the largest number. Suppose print C. Why you need not to check C as a larger compare with other two number, because already tested by A and B. A and B. Then print C is the largest number. Go to step 9. Then this all have already completed. Restore the things. So easy. Only thing you have to practice again and again as you are given in your lab manual. Compare them again, refer, write it on your own words and test it again and write it again and again. So it will become easy for you to write the flowchart for any problems and algorithm as well. Okay. So print 1 to 10. So I'll see one more problem. Print 1 to 10 numbers. How do you write a flowchart? Start with this. Read the number. Suppose you have to, because the first number it will be the A. It will be assigned to one of the variable A. You have to read it. Then go to the next step. You have to print A. First number will be printing it. Then I'll check that A is less than or equal to 10, because A is the first number. I am assigning it. One has to print it. Then I have to check that A is less than or equal to 10. Then I'll repeat the step. True, go back and A get incremented by 1. Then print. Right? So we'll check true, print. Check true, print. Suppose A is greater than or not greater than or equal to 10, false. So if it is false, then you have to stop. Right? So similarly, how do you write the algorithm for printing 1 to 10 numbers? First you have to initialize it. Similarly like this, you initialize to A is to 1. Then print it A. Then you have to check the condition. Repeat the step 2 until A greater than or equal to 10. This you have to printing again and again, and until A less than equal to A less than equal to 10. A less than equal to 10. I think I have done the mistakes here. A less than equal to 10. This will be print A. Okay. So this have to small correction. Please have to make it, this is A is less than equal to 10. When it is not less than equal to 10, then this path will be failed, become false, then it will go and stop. So similarly repeat a step until A less than equal to 10. So it is getting increment by 1. That means A is equal to A plus 1. Stop the process. Okay. Hope you understand this concept. Thank you.